X and Y.
X's, Y's, yeah. There's an X up here, and there's a Y down here. Both of them are pretty much alone, right? They aren't completely alone, but most important is that they don't have a coefficient, so we can isolate one of them. So yes, substitution is the way to go here. Now, does it matter which one I choose? Or let me rephrase that. Does it matter which variable I isolate?
No.
Nope.
No.
No. Either way is all good. So I'm just going to go with equation A. You could have done equation B and gotten the same exact answer. I'm going to isolate my x variable. What should I do to both sides?
Subtract 6.
We're going to take away that 6. Okay. All right, so I'm left with 2y minus 6 equals x. It's a little bit backwards, right? It's usually we see it this way. Usually it would be x equals 2y minus 6. However, it's the same exact, you can write it both ways. It's the same statement. Nothing about it is any different. So I know that this section right here, 2y minus 6, that's what I'm going to plug in the next step. So step 2. Which equation do I plug this into?
B.
B.
Good. And what variable am I plugging it in for?
X.
X.
Beautiful. All right. Plugging it in. Now what do I do?
Distribute.
Multiply.
Good. Multiply, distribute. 3 times 2.
6y.
And then 3 times negative 6.
Negative 18.
Negative 18.
Good. All right. Now there's a situation here. What needs to happen?
Take away the 7.
Take away the 7. That is not incorrect, but there's something that I would personally do first.
Subtract y.
Right. Why do you want to do that?
So you keep the variables on one side.
Exactly. Yeah. I have variables right now on both sides, right? I've got a variable on the left and the right, but I want them all in one place. So I'm going to take away y so that it comes over to the left side. Now, what Ajira said wasn't wrong, right? You could take away the 7, Ajira. But remember that before you start moving around numbers, you want to just make sure that your variables are all in the same place. So 6 minus 1, that's 5. Okay, now what can I do?
Add 18.
Good, add 18. 7 plus 18?
25.
25. 5y equals 25. I divide both sides by 5. 25 divided by 5.
5.
5.
Is 5. All right, so y equals 5. What do I do in the last step?
We add the 5 to our original equation.
Good. Now I could choose top or bottom, does not matter. I'm going to choose top. So 2y equals x plus 6. And then I'm just going to plug that in for y. So I plug in 5. 2 times 5 is 10. And how do I get the value of x?
Subtract 6.
Subtract 6. 10 minus 6 is 4. 4 equals x, which means x equals 4. Now, which one is it, A or B?
A.
A. Just don't forget, x comma y. So x is 4, y is 5. That means it's answer choice A. Okay, I'm seeing one question in the chat I want to address. Somebody says, I thought we were supposed to multiply 2 in the bottom and 3 in the top. So that would have been elimination. That would have been elimination. But there's something very, very, very important. And this is a very, I'm glad you asked that question because this is very important. If you want to do elimination, which is where you have to multiply, right, the top and the bottom in order to get, what is the goal of elimination? You're trying to get what?
Solution.
Well, yes, a solution. What is the goal of the first step? When you multiply the top and the bottom, why are you doing that? What are you trying to create that will help you find the solution?
Slope intercept?
Mm-mm.
An opposite equation.
There it is, opposites, right? So like, for example, this is a fake problem, we're not doing it. But let's say we're doing this, ready? Okay. Let's say I was working on that problem. What would I multiply by and why?
You'll multiply all the equations by. Wait. No. You multiply the top equation by 3.
The top equation times 3. Okay, good. What would that create?
9x plus 6y plus 21.
And in other words, the y's would eliminate, right? I would have a positive 6 and the negative 6, and they would cancel out. So what I'm trying to get at is that elimination, in order to do elimination, things have to cancel out. And in order for things to cancel out, they have to be written in order. X on top of X, Y on top of Y, right? Because then they were, like we said, we had a 6Y and then a negative 6Y. So when you line them up, they cancel out. Now, in this example, are things lined up properly?
Which example?
In the one in this example.
No.
No, right? What's going on? We have a 2y on top of a 3x, and then we have an x on top of a y. So things are not lined up, which is another reason why we couldn't really do elimination. We had to do substitution because our equations were not lined up. X on top of x, y on top of y. Does that make sense?
Yes.
Cool. Okay. Any other questions on this problem? Okay. So this was all from the review thing that you guys had to do on Friday that most of you did not do. So if you didn't do it, this is your chance now to see those problems and understand them. Take a look at the systems of equations shown below. Which system has no solution? Select all that apply. When I see this, what do I know is going to happen?
It's gonna be more than 3 choices.
Not more than 3. Be careful. It's going to be at least how many? At least?
Oh, at least 2.
2. Okay, so it could be 2, 3, 4. If you see select all that apply, don't pick just one answer. I can't tell you how many times I've looked at somebody's responses on a test and they only chose one answer or they chose all the answers. They're not going to do that either. Don't choose every single answer either. That's just nonsense. That's not going to give you the right answer. So if you're going to be guessing, make it a smart guess, please. For the love of God, make it a smart guess. So we know we're choosing probably 2 or 3, maybe 4, but let's find out. Which of the systems has no solution? So what is one that we can just look at and we already know?
A.
Good. Good. Because what do we know about no solution?
It has parallel lines.
Parallel lines.
Good. Parallel lines. Okay. B has one solution. What is C?
Infinite
solutions.
Good. All right. And then for the bottom, we have 3 systems that we have to sort of solve, or we can kind of see if there's a pattern. So in D, does anyone notice anything interesting about D?
It's infinite
How do you know?
because the multiple of the bottom. I mean, yeah, the bottom is the multiple of the top, or is it? Or am I doing it like up? Like
So you're right that it's infinite, or no, actually, no. It's hard to tell. Let me just go back a little bit. Before you even know if it's going to be infinite or no one solution or no solution, whatever, just what is the pattern you guys see in D?
All the variables are isolated.
All the variables are isolated,
In a line.
in line, they're lined up, X on top of X, Y on top of Y. And then what happens? What's similar and what's different?
the -2 is multiplied by 2.
Okay, so this was like kind of multiplied, right? Well, let's try and solve it using elimination. Let's say, okay, I'm going to try to solve this. If I wanted to do elimination, I need to have opposites, right? So I need to have a positive and then a negative. How can I make that happen?
We have to multiply by a number to make them opposite.
Okay, and what number could I multiply that would allow me to cancel things out, to make it opposites?
2.
By
Neg-
2?
Because-
Negative.
Yeah, because we need to make one of the variables a negative so they could like cancel out.
Right, right. So remember, what we're trying to cancel out is a variable. Not the number on the end, but a variable has to cancel. So in order to make that happen, I could multiply this by -1. Now, why would I do that? Let's see what happens. The top one would remain exactly the same. And then on the bottom, I would get -x, I would get -y, and I would get -4. See how that works? All you do, multiplying by -1 just helps me to turn it into a negative. Well, if I was like, okay, now I'm going to add this, what happens to the x's?
Cancel,
Cancel out.
How about the y's?
cancel,
Cancel.
So what am I left with on the left side?
-8. I mean,
On the left side,
left. Oh, 0.
0, right? Everything canceled out, I'm left with 0. What about on the right side? -2 minus 4,
-6.
-6.
-6. Does 0 equal -6?
Oh no.
No.
No. So what is this?
A non-solution, no solution.
No solution. Yeah. Which is actually what we wanted, right? We wanted to find all the ones that have no solution. Now, we did the work, so I proved to you that it's no solution, but you can also kind of see it really quickly by noticing that the x's match, the y's match, but the numbers at the end, they don't match. So basically what this tells me is that these are never going to be the same, right? Because they match, and then they don't match. So that kind of tells me, okay, these are going to be two lines that they have there's no way for them to be equal to each other. So that's just kind of a pattern that you can also look at. Why did I multiply the bottom one times -1? Why did I do that?
Oh, to make opposite equations.
To make opposites. Remember, elimination, the whole point of elimination is to have something cancel out, which means you need to have opposites. Since I had a positive y on top of a positive y and a positive x on top of a positive x, I needed to make one of those negative in order for them to cancel out. Okay, E, similar situation with E. I need to make opposites happen. What can I do to my top equation? For E, the bottom solution is a multiple of the top solution. That is very true. What is it? What do you multiply by, Lauren, in order for that to be a multiple?
4.
So if I did this times 4, now I'm going to do it by -4 just to show you guys what happens. If I do it times -4, I get -4x plus 12y equals -24. And then on the bottom, I get positive 4x minus 12y and then positive 24. What happens?
The whole equation turns, well, no.
Everything cancel out.
Everything cancels out. I'm left with 0 equals 0. Does 0 equal 0?
Yes.
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 Yeah, so this is infinite solutions. And like Lauren said, you could do the work and show that 0 equals 0, or you can notice that the top equation is the same thing as the bottom equation if you just multiply it by 4. Right? If I multiply the top one by positive 4, we get the same exact equation. And since they're both the same exact equation, that means you've got one equation and another one right smack on top of the other. That's infinite solutions. So there's two ways. You can notice the pattern, and if they're the same, that would be infinite solutions. Whereas with no solutions, they almost match, but then it just doesn't match all the way. So that's how we knew that it was no solutions. Now, very quickly looking at F, does F look like there's any similarities between the two equations?
No.
No, right? There's no way that these are going to be the same. There's no way that they're going to be no solution. So this one is one solution, and you can solve it just to see the answer, but for our purposes, it's just not the answer. So we can kind of leave it. So A and D, that was it. Do I have any remaining questions on this one? Okay. All right, number 2. We're going to do an example of solving with elimination and substitution. So starting with substitution. Which variable am I isolating?
That.
Yeah. How do I always look for the one that I can isolate?
It doesn't have a coefficient.
No coefficients, right? So this is a lonely variable. So x is already on its own. We're going to get it all the way alone. We're going to isolate it. How do I do that?
We cancel out 7y.
Cancel out 7y. Which operation do you want me to use?
Substitution.
Substitution?
Oh, I meant a subtraction.
Subtraction. Good. Okay, so I'm left with x equals
-11, -7y.
-11 minus 7y. We just keep those, even though I have an 11 and a 7, I can't add those, I can't subtract those, I can't combine those because one of them's got a variable and the other does not. So we keep them separate. Now what do I do with that?
We add it to our equation B.
Why am I doing equation B now?
Because in one of the steps for I was going to say subduction, I'm sorry. For substitution, we have to add the equation for the variable in the other equation because we can't do it for the original.
Yeah, so basically we started off with equation A. Whatever you do in step 1, you do the other equation in step 2. Otherwise, you're just plugging it into itself. You can't really plug something into where it came from. You have to plug it into the wherever it didn't come from. So that's why we go to B. Well, now I got to plug this in. Am I plugging it in for X or for Y?
X.
How can you always know? How do you know which one to plug it in for?
Because the variable we isolated is x.
Good. Exactly. That's the variable we isolated. That's what x equals. So when I go into the other equation, I plug that in for x. Okay, now what do I do?
Distribute.
Distribute. And what do I get here?
22 plus 14y.
Beautiful. Positive 22, positive 14, because a negative times a negative is a positive. Now what?
We combine like terms.
Good. 14 minus 5.
9.
9.
Awesome. We're almost there. What now?
We move the 22 by subtracting.
By subtracting. Good. Why did you choose subtraction?
Because the 22 has like an invisible positive sign in front of it, and we need to do the opposite of that.
Perfect. Perfectly said. All right. Finally, we're left with 9y. And then what's 4 minus 22?
Negative 18.
Good. Negative 18. Nice. And finally, what do I do to both sides?
Divide by 9. Y
Divide by
equals
9.
-2.
Perfect. Perfect. Nice job, Christopher. -2. Good. Good job. Any questions on this one? And I'm seeing some correct answers in the chat as well. We're not done though, but so far, any questions? All right, what's my last final step?
Find the x.
Find the x. I got y, now I need to get x. Should I plug my y into the top or the bottom? Which one's easier?
Top.
The top.
Elimination would have been a little more easier.
Top one's a little bit easier, right? Because when I say easier, it's like you just want to see which one has like less numbers or easier numbers. And I see that equation B has a lot of negatives in it, so I don't really want to mess with that too much. All right, so I'm just plugging this in for y now. 7 times -2.
Negative 14.
-14. And now I'm going to just, what am I doing now?
Add 14.
Add 14 to both sides. -11 plus 14. What do I get?
3.
3.
Good, 3. So that's my solution. 3, comma, -2. Questions on this one? Substitution. This is it. Last time I go over it. Now is your final chance. Going once. Going twice. All right, elimination. Now, how do you identify when you have a problem that will be very good for elimination?
When the variables have coefficients in front of it.
Good. Every variable has a coefficient. 8x, -6y, -2x, +6y, right? Everything has a number in front of it. That's how you know it's a good idea to use elimination. So what happens here? Do I need to multiply?
No,
Why? You're correct. Why?
because we already have opposite coefficient,
Yeah, where?
the -6 and the +6. Why?
Beautiful. So sometimes you actually don't need to multiply, because if you already have negative and positive, if you already have opposites, you don't need to do it. You don't need to use that step. So since we already have opposite values, I can just go ahead and combine my equations. So 8 minus 2,
6x.
6. My y's we already know, they cancel. And then 36 plus 0 is just 36. So if 6x equals 36, what can I do to both sides?
Divide by 6.
So I get x equals
6.
6. Now what do I do?
We plug that into our other equation.
Should I plug it into the top to A or to B?
And whichever, but I would
Whichever.
probably-
You would do B? Sure, let's do B. Okay, plugging this in for B. What's negative 2 times 6?
negative.
-12.
Negative 12 plus 6y equals 0. What should I do to both sides?
Positive. I mean, yeah, we have to add 12.
We're going to add 12. 0 plus 12 is simply 12. And finally, we just divide both sides by 6, giving me y equals 2. 6 comma 2. So this one was actually pretty easy because we did not have to do that first step. But does anybody have any questions on it?
The only reason I got this wrong was because I divided wrong. I thought 36 divided by 6 was 2.
Oops. Oops. It's okay. Sometimes that happens. But what could you always do? Let's say you get your final answer. What can you always do to check your work?
Do it again?
You could do it again. You could. Does anyone remember from, I think I did this on Thursday. How can I got my answer, right? What could I do to check it right now?
Oh, we have to plug it in.
Yeah, if I plug those numbers back into my equations, they should work. So for example, let's say I plug it back into equation A. So I'm just checking my work, just check. And so I go, okay, 8 times 6 minus 6 times 2. 8 times 6 is 48, 6 times 2 is 12, and 48 minus 12 is 36. So this is good to go, right? I'm done with the first equation. Then you would check it with the second equation and it should also work out. But let me just show you what I mean. Let's say, Ijara, you said you got x equals 2.
And then I got y equals 4/6.
Okay, so let's say you wanted to just check that. Let's say you got 2 comma 4/6. And you just want to check, sometimes there are fractions. Sometimes they show up, but you just want to check to make sure that they're correct. So you would check, okay, 8x minus 6y equals 36. 8 times 2 minus 6 times 4/6 equals 36. 8 times 2 is 16. 6 times 4/6. Anyone want to tell me what that would be?
It will give us 6, right? Because of the denominator?
You're on the right track.
It's 4. It's 4.
4, yeah. This will give you 4. 16 minus 4 is 12. Does 12 equal 36?
No.
Nope. So at that point, you would say, oh, I messed up somewhere. Let me go back to the beginning and check my work and try it again. How is that 4? 6 times 4/6. What cancels out?
The denominator.
Yeah, 6 and 6 cancel out. You're left with 4. You could also do it the long way. What's 6 times 4?
24?
24. This is 24/6. What's 24 divided by 6?
4.
4. You get 4 either way. Okay, so again, that's just the ability to check. That's something you can always do if you have time on a test to do so. Always check your work. But in our case, we got 6,2. Any other questions on this one? Okay. All right. Practice problems number 3. This was number 3 on the test. No, number 4, my bad. Okay, Joni states that the two systems below are equivalent. Which statement below is true? So first of all, equivalent systems. There's 2 ways. How can you get an equivalent system? There's 2 ways. How can I do so? A lot of y'all struggled on this, and I think it's because a lot of you guys are overthinking it. How do I make something that is still, that gives me the same solution?
Multiplying?
Multiplying. So if one equation is a multiple of another, so for example, in this case, let's look at system A and system B. Do we see any multiples?
Yes, the 2 bottom equations.
The 2 bottom equations, right? How do I go from one to the other?
Multiply by 2.
Times 2. Right? I have the bottom equation from B is a multiple of the bottom equation from A. So what this means is that basically this equation is good to go. That fits the bill. It passes the test. But both equations have to go. Both equations have to have a check mark. Is the top equation a multiple?
It could
No.
be, maybe, because like
You have
I got
to
confused
add it
with the-
first.
Oh, wait, hold up. I heard Lauren say something. What'd she say?
You have to add equation A, and then you'll get the top equation.
Yeah, so that's the other way. If one equation is the sum or difference of system A. So notice how if I add this, just like we usually do with elimination, we can add the equations together. That would be 3 plus 1, that's 4. 1 minus 4 is -3. And 8 minus 6 is 2. So see how that matches? The sum of system A is the top equation of system B.
Oh, okay. See,
So I
I
can-
chose B.
Okay. So this is something that I think a lot of you guys, again, I think a lot of you guys just either forgot it or we didn't practice it enough or you were overthinking it, but it's as easy as that. If you have 2 systems and you want to check if they're equivalent, first thing you check for is multiples. See if one of those are a multiple of the other. So for us, the bottom one was a multiple. And then you can check to see if any of them are the sum or the difference. So this one, oops, this was the sum of system A. And that's the only 2 ways that it works. So if it matches that way, then you're good to go. And both equations have to match. So in system B, I gave both of them a check mark because they both match. So I already know that they are equivalent. So Joni is correct. And then the reason, like we said, I believe it's answer choice C. The systems are equivalent because the top equation in system B is the sum of the equations in system A. And the bottom equation in system B is a multiple of the bottom equation in system A. So C is the correct reason. D had the reason incorrectly. Do we have any questions on this?
So if we see a problem like this, and in the answers it says like the sum of the equations, that means we have to like add one of these equations to see if it's the right thing.
Right, exactly. So for example, what we did, it's just like when we do elimination where you combine the two equations together. Wherever it's, if you see a plus sign, you add. If there's no sign, that means it's a positive number, so you're still adding. So that's why we did 3 plus 1 is 4. And then 1y minus 4y was -3. And then 8 minus 6 was +2. That's what that means. Any other questions on that though? Because this one, I just want to make sure we understand this. It doesn't have to be super hard. You just have to train yourself to like see those patterns. Okay. Moving right along. Consider the inequalities below. Is 10 comma -2 a solution to the system? How do I check that?
By plugging in the solution.
By plugging those numbers in, and if it's a solution, what does it have to do?
Equal to, wait. If it's a solution, what does it have to do?
Like if something is a solution, okay, let's actually just plug it in and see what I mean. Which one am I plugging in for x?
10.
10 is x, and -2 is y. Okay, I'm plugging it into A. 10 and -2 go in. Then I do a little bit of math. What is 10 times -2?
12.
Means -6 times -2.
Right, so it ends up as a
Possible.
positive 12, yeah. 10 plus 12 is 22. And is 22 greater than 5?
Yes.
Yes.
Yeah.
So my question was, what if it's a solution, what does it have to do? It has to satisfy both equations. And by that, I just mean that it has to create a true statement. So here, 22 is greater than 5. That is a true statement. That means that it satisfies equation A. But we also have to check equation B because it has to be able to satisfy both. Not just one, but both. So what happens here? What do I get?
70 plus -4. I mean, no, 70 minus -4.
70 minus 4. You got it. 70 minus 4.
60.
66. Is 66 greater than or equal to 4?
Yes.
Yes, you can. So it satisfies both inequalities, which means yes, it is a solution. Any questions on how to do that? Okay. So in that case, there's one more very similar. I want you guys to try this one on your own. I'll give you guys about 3 minutes.
The people who have answered it already, we don't answer, right? Or
You can do so. I think I already saw your answer, but just remind me of what your answer was. Just put it in the chat.
okay.
About 1 minute remaining. All right, so let's take a look. What am I plugging in for x?
0.
0 goes in for x, 2 goes in for y. Starting with equation inequality A. Okay, -9 times 0 is 0. 5 times 2,
10.
10. Is 10 less than or equal to -6?
Mm-mm.
Mm-mm. Nope. It does not satisfy the top inequality. So I know it's not A, but now I need to check the bottom one as well so that I can choose the correct answer. Same thing, 0 goes in for x, 2 goes in for y. 4 times 0 is 0, -8 times 2 is -16. Is -16 less than -16?
Mm-mm. It's
No.
2.
No, right? If this was less than or equal to, it would work out. But since it's just less than, that is a false statement. -16 is not less than -16. Therefore, no, this is not a solution because it does not satisfy either inequality. So it doesn't satisfy either of them. So it's D. Questions on this one? Okay. I believe there was just a couple more. So here we got a graph of an inequality, and we have to match it to the correct one. Now, what can I look for? This is kind of like the way to do this type of problem. The first thing we want to do is match the lines. Now, what number can I look at so that I can identify which one is which?
The
I have-
y-intercept.
Perfect, exactly, RL. So we're going to match the lines by using the y-intercept. So what does that mean? In inequality A, what is the y-intercept for inequality A?
1.
Dash line.
It's 1, and it is the dashed line in 3 of the 4 answers, but I'm not going to match it to the line because some of them are going to be right and some of them are going to be wrong. But more importantly, I just look at that 1. I'm going to find the 1 on the y-axis. There it is. And wherever that line is that's passing through the 1, that is my A. So this is inequality A. Now, once you've identified the inequality, since I know that this one is A, that means the other one is my B. And then from there, it's just a game of match. Which one matches 100%? Because now what do I look at? Now that I know which line is which, what can I look at to identify the correct answer?
Symbol?
The symbol, exactly. So we're going to find the answer using the inequality symbols. So what does that mean? I look at inequality A is greater than. So what am I looking for?
Above and dotted.
Above and dotted. Above the blue line, and then the blue line has to be a dotted line. So which inequalities are out?
C and D.
C is out because C is below the blue line. Y'all see that? That's below the blue line. So C is out. D is also below the blue line, and it had a solid line instead of a dotted line. So that's like double out. And then for inequality B, it's a greater than or equal to. So what does that have to be?
It has to be on the left side.
But more than that, say above or below?
Above.
Above and
Solid.
solid. And that leads me to my answer, which is going to be answer choice
B.
B.
B. Oops, B. Above, so notice this area is above the green line as well as above the blue line. So it's above and above. Whereas answer choice A was above the blue line, but then it was below the green line. So it had to be above both of them. And that's basically it. So first thing is just which line is which one's A and which one's B. And then you look at the symbol to see which one is shaded in the correct place. Questions on this one?
I have a question about the shaded parts.
Mm-hmm.
So if, for example, line B, if it's shaded on the left side, that means it is positive. But if it's shaded on the right side, that means is it negative?
Be careful with that because when you start thinking about, here, let me erase everything except what we're talking about. Okay, so you're talking about line B, right?
No, I'm just talking about it overall because I've been having time to like see which side is positive and which one is negative.
So instead of thinking about positive versus negative, think about greater than versus less than, okay? Because it's not, they're kind of different things. Positive and negative have to do with like the numbers. So like the y-intercept can be positive, the slope can be positive, or it could be negative. But the symbol, okay, if it's greater than versus less than, that's just about where you're shading. So it doesn't matter if those are negative numbers or positive numbers, as long as you think about this is supposed to be greater than or equal to. So it's above the green line. So notice, I'm going to kind of ignore the other inequality for a moment. But if I'm going to shade above the green line, that is this whole area. All of this is above the green line. Now, those are positive numbers, those are negative numbers. That's everything in between because I can have one of my solutions is right here. This is like 1, 4. They're positive numbers. One of my solutions is over here as well. This would be like negative 2, 4. So positives and negatives are one thing, but try not to confuse that with above versus below. Okay, does that kind of clear that up a little bit?
Mm-hmm.
Okay. Now, since we had two different lines, the solution wasn't the whole area, because remember, what's really happening is that we're looking at everything above the green line, which is all of this, as well as everything above the blue line, which is all of this. And it's really looking for the place where those two shaded regions intersect, which is why the final solution is only this portion. Okay. Any other questions on that? Okay. All right. This is the last one, and then I think we'll have time, maybe not, but that's okay. All right, this is the last one from Friday's assignment. So this is just about getting the correct inequalities. We got to read this carefully and select our keywords and then see which ones work out. A technology company produces 2 types of calculators, and then we've got 3 kind of bullet point situations. They must produce at least 10, so I'm going to start highlighting, at least 10 and not more than 30 graphing calculators per day. And it's telling me that graphing calculators, is that my X or is that my Y?
X.
X. Good.
Wait.
Yeah, X is the number of graphing calculators. So I'm going to just start making a list that matches the bullet points. They must produce at least 10 graphing calculators. At least 10. So is 10 my maximum or my minimum?
Minimum.
Minimum, right? They have to make at least 10. So do we want it to be less than 10 or greater than 10?
Greater than.
Greater than. Can it be equal to 10?
Yes.
Yes, it can. So the number of graphing calculators must be greater than or equal to 10. And then it also says that they may not make, so they must produce not more than 30. So is 30 my maximum or my minimum?
Maximum.
That's the maximum. Can they make 30?
Yes.
Yes, but do they want to be above 30 or below 30?
Below.
So it's going to be less than or equal to 30. That's graphing calculators. Then they say, each day the number of graphing calculators cannot exceed twice the number of scientific calculators. So scientific calculators is Y. So each day, the number of graphing calculators may not exceed twice the amount of scientific calculators. So that means the number of graphing may not exceed 2 times the number of graphing. So let's rephrase that. Do we want the X to be less than 2Y or do we want it to be more than 2Y?
Less than.
Less than, yeah. It cannot exceed. It has to stay under 2Y. Can it be equal to? And then finally, the last bullet point, the number of scientific calculators cannot exceed 40 per day. So graphing calculators, do they have to stay under 40 or can they go above 40?
Under 40.
Under.
So less than or equal to 40. Now, which one's the only one that matches 100%?
A.
A. So again, these are, for these, you have to read it super, super carefully and always think, okay, is this the maximum? Is this the minimum? Do we want to stay above or do we want to stay below? And then from just that, you should be able to get your final answer. You just have to reread it very carefully. Any final questions? We have about a minute.
I only got my variables wrong. I was looking at the numbers and the symbols and the variables. So.
Got it. Okay. Well, no homework because tonight is all about studying. Since we missed these I had 5 questions at the end. I will post those on Teams. It'll be optional, but it is just more study problems to work on. So if you would like that opportunity, I will post it on Teams in about a minute. But that is that. So tomorrow is the test. That means I want you guys to think about everything we talked about today and just remember that this matters a lot. And that's not to put too much pressure on you, but it's just as a reminder that we got to work hard if we want to do well. So I want to make sure that you guys are studying tonight, looking over your notes, watching videos if you need to, just taking that responsibility for yourself. See you guys tomorrow.
Have a nice day, Miss Lopez. See you tomorrow.
Thank you. See you tomorrow. Bye.